At small scale, AI feels inexpensive. One user, one request, one response. The system runs, the answer appears, and the cost is barely noticeable. A few cents, maybe a few dollars. Everything looks sustainable at the beginning. Every user sends a request into the system. The application generates a response. Behind that response, the model runs inference. Inference requires compute, and compute is metered. Each request adds a small charge to the bill. At this stage, the numbers look harmless. A few dollars today, a fraction of a cent per request. At this stage, the bill looks insignificant. $12 today, 1 cent per request. The product works. Users are happy. Nothing feels expensive. The numbers are small enough to ignore. And that's exactly why the risk is invisible. As more users arrive, the system looks the same AI application, the same responses. But every new interaction runs another inference, and the bill grows with every request. Nothing changed in the product, only the number of users increased. One request rarely ends with a single response. Users ask follow-up questions. The system runs the model again and again. Each interaction triggers another inference, so cost doesn't grow per user, it grows per conversation. Modern AI applications rarely rely on a single model call. One component generates an answer, another model evaluates it, a third refines or reformats the output. Each step triggers another round of inference. The user sees one response, but the system runs multiple computations behind the scenes. Now cost grows per interaction and per internal step. A single user request does not trigger a single model. The application may call an embedding model. It may run a search over indexed data. Then it sends context into a large language model. All of this happens before the user sees a response. One visible answer, multiple hidden computations, and each component adds to the total cost. As products evolve, layers begin to stack. One model feeds another. Outputs become inputs. Systems evaluate, rewrite, re-rank. What looks like a single response is often the result of several passes. Each layer repeats the cost cycle, and every repetition increases total compute. Now scaling no longer means more users, it means more internal execution. A user request looks simple, but inside an AI system, it expands. The app may call the language model, generate embeddings, query a vector database, re-rank results, execute a function. So one request becomes multiple operations, and those operations are what you actually pay for. Now multiply that structure by every active user. 10,000 users means 10,000 parallel pipelines running. Every request triggers the same chain of operations, and each of those operations consumes compute. The cost per request may look small, but the total number of operations is what truly scales. 10,000 users, each making 20 requests per day. At just 1 cent per request, that feels negligible. But multiply it out, that becomes $2,000 per day. Not per month, per day. And this is still a simplified model. Now increase that to 100,000 users, same product, same interface, same 1 cent request. Nothing changed in the experience. But the daily cost jumps to $20,000. That's over $500,000 per month. And this is still just inference. Now push it to 1 million users. Same math, same assumptions. That becomes $200,000 every single day. That's over $6 million per month, and nothing about the product changed. Only the number of people using it did. And this isn't even the full picture. Users don't arrive one at a time. They generate requests simultaneously, which means the system must handle thousands of inferences in parallel. You're not just paying for usage, you're paying for capacity, for peak traffic, for the ability to answer everyone at once. At scale, every single app instance is a compute engine, each one running inference, each one consuming GPU time, each one burning tokens. Individually, it looks harmless, but when thousands of these are active at the same time, your infrastructure is no longer lightweight software. It becomes a distributed compute factory, and factories are expensive. But here's what most founders miss. You are not paying per request. You are paying per token, and a single response can easily be 2,000 tokens. Not just the answer, the input, the system prompt, the hidden reasoning, all of it counts. This is the real equation. Not just users, not just requests, but tokens. Every request turns into thousands of tokens, and when requests spike, tokens spike with them. Your real cost is number of users multiplied by requests per user, multiplied by tokens per request, multiplied by the token price. And once traffic grows, that multiplier explodes. That's how you wake up to $200,000 per day. This is the full equation. Token price, daily requests, total users, all multiplied together. That's your real daily cost. $200,000 per day, not revenue, cost. That's how fast the math compounds. 200,000 per day turns into 73 million per year. Before salaries, before servers, before profit, just model cost. In traditional software, more users usually means more profit. In AI apps, more users can mean higher losses, because usage scales cost linearly, and sometimes worse. More users means more requests means more tokens means higher cost. Revenue might double, but cost can triple. More users, more requests, more tokens, more cost. If your margins are thin, growth can kill you. AI startups have a structural problem. Their product is someone else's infrastructure. Their margins depend on token pricing they don't control, and growth magnifies the risk. In this model, more users doesn't mean more profit. It means more burn. The faster you grow, the faster you lose money. Your revenue per user is mostly fixed. Subscription, maybe usage tiers, but your cost per request can keep rising with longer prompts, more features, more generation, and that gap is where startups break. In traditional startups, scale increases profit. Infrastructure cost per user goes down. In AI startups, scale can increase loss because every interaction has a real variable cost. AI doesn't scale like software, it scales like compute. Every request consumes GPU time, and GPU time is money. Compute equals cost. A user request becomes GPU compute. GPU compute produces tokens, and tokens become real cost. Every response is literally burned compute. More users doesn't mean more profit. In AI, growth alone isn't leverage. More users can mean more cost. If revenue per user doesn't exceed cost per request, growth just scales losses. AI is not software. Software scales with near zero marginal cost. AI scales with compute, and compute has a price. Scale isn't just about performance, it's about the bill. If you scale AI, you scale cost. Plan accordingly.